I want to go over another one of these problems that we had in this lecture worksheet from today. So looking at question 4, which of these compounds would undergo a conjugate addition with an enamine? And we're going to follow that by trying to complete the reaction of a given enamine with the compound that we're choosing. So if we look at the 4 possible compounds that we have, we want to do a conjugate addition reaction. That means we need to have an alpha-beta unsaturated carbonyl. We only have one alpha-beta unsaturated carbonyl. So compound B has to be the compound that we're looking at. So let's see if we can figure out what happens as we take this enamine and react it with compound B. So here we have our enamine, and we have compound B. The conjugate addition reaction, we're going to use these electrons to form a carbon-nitrogen double bond, and then this alpha carbon here is going to be our nucleophile. That is going to attack the beta carbon, so alpha beta carbon, of our electrophile. So this alpha carbon is our nucleophile, this beta carbon happens to be our electrophile. And we can push the electrons all the way up to that oxygen. So after this addition, what we end up with is something that looks like this. Now, if we had given some kind of a solvent, we could be protonating this to get us back to the ketone. Usually these reactions are worked up by treating them with aqueous acid. Now, the aqueous acid can be used to protonate our enolate and also can tautomerize the resulting enol to a ketone. We can try to draw that in such a way we could actually reform the carbonyl and then have this get protonated. That gives us the carbonyl back here. Now, under these aqueous acid conditions, this enamine can also be hydrolyzed. When we hydrolyze that, that's going to go back to the carbonyl as well. So after that hydrolysis, the final product that we get is going to look something like this. And we can track all of the carbons from our starting material. This is the portion from our enamine. That's right here. And then the ring system and that carbonyl are from our alpha-beta unsaturated ketone, and that's what we have here. There's the beta position that we ended up attacking. Here's the alpha position that acted as a nucleophile at the beginning. So this is an example that's taking the enamine, which we did alkylations and acylations with enamines. Now we're seeing an example where we can do a conjugate addition or a Michael addition or a 1,4 addition onto an alpha-beta unsaturated ketone.